In this video, I want to talk about multiplying expressions that contain complex numbers. So here we have x minus 3 plus 8i, and I'm going to multiply that with x minus 3 minus 8i. So it looks like a lot of this stuff is the same, x minus 3, x minus 3. The only difference here between these two expressions is that one is positive and one is negative. So it looks like the x minus 3's are the same, and it looks like my 8i's are the same. So I could use the notion of difference of squares, because a plus b and a minus b, to multiply this a lot more efficiently. Because the alternative would be to take the x, distribute them through these three terms, take the negative 3, distribute, take the 8i, distribute, and then we'd have 9 terms, and then we'd have to go hunt and find all the common terms, or the like terms. So what I'm suggesting here is that based on kind of the form or the way this multiplication looks, I can take a shortcut. I can generalize this a little bit and make it easier on myself. So the x minus 3's can be squared, and then I'll subtract from that the 8i squared as well. So our difference of squares is going to make this much simpler. So x minus 3 quantity squared will become x squared minus 6x plus 9, and then when I square the 8i, it becomes 64i squared. And of course we know that I squared is negative 1, so that'll change the subtraction to an addition. So x squared minus 6x plus, and it looks like 73 then, will be the product when I multiply these two expressions that contain complex numbers. In this second example, I kind of want to take a similar approach to what I just got done doing in the previous example. I see that I have 4 terms being multiplied by 4 terms. They have a lot in common. We have some sign differences here, minus and plus, and then plus and minus. If I were to multiply all this out long ways, 4 terms times 4 terms would give me 16 terms. That's a lot of multiplication and a lot of addition of, common terms or like terms. So I'm going to try a different approach. I'm going to try my difference of squares again. So I have my x plus 2 here and here, which are the same. But what I notice here is that these signs are opposite from one another in those two last terms. So I'm going to do a little thing here. I'm going to factor out a negative. So x plus 2. And now what I see, x plus 2, square root of 5 minus 2i, square root of 5 minus 2i. One of them is positive and one of them is negative. So I can use my difference of squares, a minus b times a plus b. So in order to facilitate this much more efficiently, it's x plus 2 squared minus the square root of 5 minus 2i squared. So now I just have 2 perfect squares, and I can easily use my little formulas to do that. So when I have something like a plus b squared, I'm going to square the first one. I'm going to multiply the 2 terms and double it, so plus 4x, and then the square of the last term there, so plus 4. Then I have this minus sign, so I'll put this next square in parentheses so I don't mess this up, because I'm going to have to distribute that negative through. So the square of the first one makes 5, minus twice the product. So double this is 4i, so I'll have 4 radical 5i, and then square the second one, so plus 4i squared. Of course, the I squared is negative 1, so I'll change that into a minus. So let's distribute now. So x squared plus 4x plus 4 minus 5 plus 4 radical 5i plus 4. So we have 4 minus 5 plus 4, so all my constants will become 3. And then I have x squared plus 4x plus 3 plus 4 radical 5i. And that was a much quicker process, a lot cleaner. I would challenge you to go ahead and multiply all of these out and see all 16 of those terms and realize that this is a much quicker approach. Also kind of generalizing, using the pattern of what we're given, we'll manipulate that a little bit to meet our needs, to make it a lot easier, a much more efficient process than having to go a long way. So here we go, this is the product of these two expressions that contain complex numbers.